Alrighty, so looking at exponential equations. What we are doing today is we're looking at how we use log BAP and our exponential equations more with real life concepts and applications. So we have our exponential equations can be solved using logarithms or our change of base formula. So we have our first example here is solving 5 to the power of x equals 7. So our first step is to take the logarithms of both sides. So what we have is we have 5 to the power of x equals 7 is our formula. And what we are going to do is we are going to multiply both sides by log or ln, it doesn't matter. And so what we do is when we multiply both sides by a log, we get log of 5 to the power of x equals log of 7. Okay, what we want to do from here is we want to use our log properties, our log law, where it's log a to the power of n is equal to n log of a. And so what we do is when we have our unknown in our power, we can bring that down out the front so that we have x log of 5 equals log of 7. From here, what we do is we just divide both sides by log 5. And what we get is we get x equals log 7 over log 5. We put that into our calculator to get x equals 1.2096 ... and so x equals 1.2 to 1 decimal place. So that is one method of solving for the power of x. Okay. Our other method is to use our change of base formula and to convert from a exponential to a logarithm. So what we have is we have log BAP. Log BAP is something that you need to remember for the rest of high school. Okay, so with log BAP, what we have is we've been given 5 to the power of x equals 7. And so it converts to, well, our 5, our base. We have our power is our x. And we have our answer is our 7. So what we will have is our exponential converts to log of base 5 of 7 equals x. Now, pause. Everyone can put that into their calculator because everyone sitting here has the new calculator, okay? But if for some reason you didn't have the new calculator, what you would do is you'd use x equals log of base 5 of 7, and we would put that into our calculator. But if you don't have the new calculator, you would use our change of base formula, which is on our reference sheet as log of base a of x equals log of x over log of a. So what we get is x equals log of 7 over log of 5. X equals 1.2096 ... So x equals 1.2. Okay, but what we can do is just put in calc. So our calculator helps us and we don't have to do as much working out. Does that make sense? Okay, so that this is where the perk of the calculator really comes into play. Okay, anyone got any questions? No? So, for example, when you do your yearly exam, you probably should take both calculators into your yearly exam in case one of them dies or something happens, okay? And so if for some reason the new calculator dies, you've got the old one sitting there, so you still need to know how to do this so that you don't have like a full-on freak out. Okay, unless you buy 2 of the new ones as an example. Okay, question 2. We are going to solve e to the power of 3.4x equals 100 correct to 2 decimal places. So we have e to the power of 3.4x equals 100. What do we think we should do? We're going to solve it for x. So we need to convert it from an exponential form to a log form. So we'll have to use our log BAP. Converts between base power equals answer. So what this means is we will have that this is going to be log of base e of 100 equals 3.4x, because we have our base is our e, we have our power is our 3.4x, and we have our answer. The iPad is not playing today, is it? Our answer is our 100. Okay, so getting really comfortable with converting between an exponential and a log is going to save you. Now, what we want is we want to solve for x. So to solve for x, we don't want that 3.4 out the front. So we're going to divide both sides by 3.4. So what we will have is that x equals ln 100 over 3.4. Because remember that log base e is equal to ln. We then put that into our calculator, so we get x equals 1.3544 ... So 2 decimal places, our answer is 1.35 to 2 decimal places. Now, you might be sitting there going, okay, cool, we haven't really done anything new yet. What we're going to be doing now is looking at how we can do it with a real life scenario. So when we're talking about exponentials, we generally talk about exponential growth and decay. So what we have is when something is getting hotter, or when something's cooler, or a population is growing or decreasing in size, that is exponential growth and decay. Now, in extension, you have to learn how to create that formula, but in advanced, we just get given the nice formulas. We don't have to make sure that we know how to get to them, okay? So all we have to do is, we've been given that the temperature T in degrees Celsius of a metal as it cools down over T minutes is given by the formula T equals 27 plus 219 e to the power of negative 0.032 T. We want to find, correct to 1 decimal place, the time it takes to cool down to 100 degrees Celsius. So what we're going to do is start off with our formula T equals 27 plus 219 e to the negative 0.032 T, and we are going to let capital T, because capital T is our temperature, equal 100 degrees Celsius. So what we will have is 100 equals 27 plus 219 e to the negative 0.032 T. What we are finding is T, we're finding time. So we need to rearrange this to make little t the subject. So what we need to do first is minus our 27 from both sides, leaving us with 100 minus 27 is 73, equals 219 e to the negative 0.032 T. Okay, then what we're going to do is we're going to divide by our 219. When we divide by our 219, 73 over 219 in my calculator actually simplifies down to a third. That kind of looks like a 7, so I'll fix that. To a third equals e to the negative 0.032 T. Okay, now that we have our base of e with nothing in front of it, we can log BAP this. So what we will have is it is log of our base of e of our answer of a third equals negative 0.032 T. Does everyone get that? Or do I need to use the colours? No? Okay, from here, we want to find T. We currently have a negative 0.032 times to our T. So what we're going to do is divide both sides by negative 0.032. So we'll get T equals ln a third over negative 0.032. So we get T equals 34.3316, 3402. Okay, and we want the answer to 1 decimal place. So T will, stay still, what is going on? T will equal 34.3 minutes. Okay, and because we love a worded question, we should write our answer in words. Therefore, it takes 34.3 minutes for the metal to cool down to 100 degrees Celsius.